A single coin-sized magnet sits inside the positioning stage of every extreme ultraviolet lithography machine, ASML, has ever shipped. That magnet is wound from neodymium and doped with dysprosium, and as of late 2025, the country that refines both of those elements to the purity that magnet requires set a clock on the supply. Not a ban. A clock. The question the map in this video has to answer is whether the West can route a new line to that magnet before the clock expires, and what happens to the machines that print 3 nanometer silicon if it cannot. Every breakthrough and every crisis in this industry is a change in the shape of a network. Not a policy announcement, not a faster chip, not a headline. A line rerouted around a node that used to be a choke point, or a node that closes with no detour drawn. This video traces one wire from a diplomatic agreement signed in late 2025 all the way down through the refinery, through the magnet, and into the wafer stage of a machine that costs roughly $200 million to build. Every node the wire passes through gets read for whether a bypass exists or whether the line simply ends. In October 2025, China suspended the rare earth export controls it had been tightening across the prior year. Suspended, not lifted. The suspension runs to roughly late 2026, and that date has been left visible in every public statement about it. Trade and financial press reported the structure of the announcement consistently. The restriction is paused, the underlying authority remains, and the expiry is not ambiguous. What the suspension actually covers is less universally understood. The phrase rare earth travels through public conversation as though it names one substance. It names a family of 17 elements with radically different supply concentrations and radically different technical functions. In an extreme ultraviolet context, the subset that matters is narrow and specific. The positioning stage inside an extreme ultraviolet machine moves a silicon wafer with sub-nanometer precision, while the machine's optical system generates intense magnetic fields from surrounding components. The magnets that drive that stage need exceptionally high coercivity, which is resistance to demagnetization, because a positioning magnet that loses field strength under thermal or magnetic load produces inaccurate exposures. Neodymium-iron-boron provides the bulk field strength. Dysprosium, diffused into the grain boundaries of the neodymium alloy, holds that strength at the temperatures the machine reaches during operation. Samarium cobalt appears in some high-temperature positioning components where the thermal environment exceeds what a neodymium alloy can tolerate. These are not procurement preferences. They are specifications set by physics and by the machine's exposure tolerance. When the October 2025 suspension opened a window, what it actually opened was a window on a very specific subset of the rare earth family, the ones a positioning stage cannot be built without. Think of it as a single bridge on a highway network. Every truck moving through the system passes over it. The bridge authority announced the toll booth is unmanned until late next year, and traffic is moving freely. But every logistics planner on the network is now running the same calculation. What happens to the route when the booth reopens? And is there a second crossing that can be qualified before that date? The trucks are moving. The bridge is open. The calculation is the point. My read of the October suspension is that it is not a thaw. It is a calibrated display of the timer. China did not remove the controls. It paused them long enough for every chip buyer in the world to calculate exactly how exposed they are, then left the expiry date in full view. The strategic information being transmitted is the clock itself, not the reprieve. Note: the October 2025 rare earth export suspension. The line reads, "No bypass drawn. The suspension is a pause on a restriction, not a structural rerouting, and the underlying choke point remains intact beneath the open window." Follow the wire from the suspension into ASML's response, and the first thing you reach is the company's resilience program. ASML has publicly disclosed spending of roughly €1.25 billion on supply chain security, a figure from the company's own statements. Part of that program is inventory. The company has been building buffer stock of critical components, including magnet assemblies, since the controls began tightening. Analyst and press reporting characterizes the effective cover as measured in months rather than years, with estimates around a couple of months of production capacity held in reserve. ASML has not confirmed a precise inventory figure publicly, so the month's characterization should be read as the market's best estimate, not a company disclosure. Read that number on the map. A buffer measured in months against a restriction that could lapse in late 2026 or extend indefinitely if the suspension is not renewed is not a detour. It is a margin. The difference between those two things determines what happens at the far end of the line. A detour is a new road that routes around the choke point entirely. A margin is the amount of fuel in the tank when the only gas station on the route is temporarily closed. A full tank gets you through a short closure. It does not get you to the destination if the station never reopens. ASML's buffer is the tank. The qualification of a new supplier outside China is the station. Here is where I want to test my own read of the program. The spending is real, and qualifying alternative suppliers is part of the disclosed strategy. But qualifying a magnet supplier to extreme ultraviolet specification is not a procurement exercise. It is a materials science problem. The grain boundary diffusion process that gets dysprosium into a neodymium magnet at the right concentration and the right spatial distribution to meet coercivity targets at operating temperature requires process knowledge that very few facilities outside China have demonstrated at production volume. Reports suggest Western and Japanese suppliers are in qualification trials. No independent source has confirmed volume production at extreme ultraviolet purity. If the resilience program is weighted toward inventory accumulation rather than supplier qualification, it is solving for the wrong time horizon. And the company's own disclosures do not yet make that ratio clear. The coin-sized magnet the map has been following since the first segment is sitting in a buffer on a shelf somewhere in ASML's supply chain. The question is whether a second magnet, made outside China, will be qualified and available before the one on the shelf runs out. Node: ASML's Rare Earth Magnet Stockpile and Resilience Program. The line reads, bypass in construction with no confirmed volume. The spending is real and the qualification trials are running, but the line from a non-Chinese supplier to a delivered extreme ultraviolet magnet assembly has not been closed. Now the wire forks, and this is where the map looks different from the version most coverage has been drawing. Trace the line back past ASML's inventory, past the suspended controls, to the point in April 2025 where China imposed a separate set of export restrictions. Before October, before the suspension that generated most of the headlines. In April 2025, China imposed controls on 7 heavy rare earths: terbium, dysprosium, gadolinium, lutetium, samarium, scandium, and yttrium. These elements were publicly listed in the Chinese government notice at the time. These controls were not suspended in October. They remain in force. Read what runs through this fork. Dysprosium is on the April list. It is the element diffused into the grain boundaries of the coin-sized magnet this map has been following. The October suspension gave some relief on neodymium and lighter rare earths. It left the heavy elements, the ones that determine whether a magnet holds its field at the thermal loads inside an extreme ultraviolet machine, under active restriction. The image I keep returning to is 2 valves in series on the same water main. The downstream valve was partially opened in October, and pressure at the tap improved. The upstream valve, the one that controls whether the water carries the specific mineral content this particular pipe requires, was tightened in April and has not moved. Measuring only the downstream valve gives you a false reading of the flow at the tap. The April controls have received less attention precisely because they did not come with a visible timer. A permanent restriction on dysprosium and terbium is a harder structural constraint on magnet performance than anything the October truce temporarily lifted. A neodymium magnet without dysprosium loses coercivity at elevated temperature. An extreme ultraviolet machine running at operating temperature with a demagnetized positioning magnet does not produce accurate exposures. It does not produce a usable wafer. The April controls did not get a countdown. They got silence. And on this map, weighted correctly, they are the more consequential node of the two. Between the mine that produces the ore and the magnet sitting in the positioning stage sits a chain that most discussions skip entirely. Finding rare earth ore in the ground in Australia, the United States, or parts of Africa does not put a finished magnet on a shelf. Between extraction and a delivered assembly sit separation chemistry, oxide reduction, alloying, pressing, sintering, and grain boundary diffusion, each step requiring its own certified facility and its own process expertise. Finding iron ore in a mountainside does not put a finished bearing in an engine. The ore is geography. The magnet is decades of accumulated process knowledge, and that knowledge has been concentrated in Chinese facilities through sustained industrial policy over time. The April controls restrict the elements that flow through the far end of that chain. The October suspension opened a window on the nearer end. The window is visible. The upstream valve is the constraint. Node: the April 2025. Heavy rare earth controls, 7 elements, never suspended. The line reads, no bypass drawn. The restriction on the specific elements an extreme ultraviolet magnet needs at operating temperature is active, unpaused, and the wire that runs through it has no confirmed detour. Now the map reaches the one node where the line does not continue. A domestic rare earth magnet supply chain outside China, capable of producing neodymium-iron-boron magnets at the grain structure purity and coercivity consistency an extreme ultraviolet positioning system demands at production volume. That supply chain does not currently exist. The process knowledge for grain boundary diffusion of dysprosium into a neodymium magnet at extreme ultraviolet specification has been built up in Chinese facilities over decades. Mines in other countries produce the raw ore, but ore in the ground is not a magnet on a shelf, and the processing and manufacturing chain between them takes years to certify for any precision application and longer to certify for the specific tolerances a positioning stage demands. No confirmed production volume supplier outside China has cleared that certification for extreme ultraviolet grade magnets. The purity specification that coin-sized magnet requires is the wall no Western supplier has cleared at scale. It is the one point on the map where the wire terminates without a detour drawn. The strongest case that this dead end is permanent rests on time and process depth. The April 2025 controls restrict the dysprosium the bypass depends on. Building the bypass requires access to the ingredient the restriction limits. That is a circular constraint, and circular constraints have a way of staying circular unless something external breaks them open. The strongest case that a bypass is coming rests on the depth of expertise in Japan. Shin-Etsu Chemical and TDK have operated at the leading edge of high-performance magnet technology for decades, and some published materials, science suggests that microstructure optimization can reduce total heavy rare earth loading in a magnet without fully surrendering coercivity, which would reduce, though not eliminate, dependence on dysprosium. Western governments have flagged rare earth processing as a strategic priority and committed funding to accelerating qualification timelines. Reports suggest companies including MP Materials in the United States and several European processing initiatives are moving toward heavier element separation capability. If qualification trials produce confirmed volume within the suspension window, the bypass could be drawn before the October 2026 clock expires. The synthesis that holds both reads at once is this: the bypass is being built, but being built and built are separated by exactly the variable neither the suppliers nor the governments funding them fully control, which is whether qualification time and suspension duration fall in the right order. The April 2025 controls mean the bypass has to be constructed without full access to the key ingredient while the construction is underway. That is not an impossible constraint. It is a very tight one. Read the full map now. 3 segments, each closing on a node. The October 2025 suspension. No bypass drawn. A window with a close date, not a rerouted line. ASML Stockpile and Resilience Program. Bypass in construction. Real spending. No confirmed volume from outside China. The April 2025 Heavy Rare Earth Controls. No bypass. Drawn, active, unpaused, targeting the specific elements that determine whether the magnet holds its field. And the dead end. A domestic supply chain at extreme ultraviolet purity that does not exist at production volume yet. With the qualification trials running against a clock set by the Truce, those same trials depend on outlasting. This network is not close to self-sufficient on the Western side, and the October suspension has created a specific danger that I think is underappreciated. The window feels like a resolution when it is actually a countdown. The coin-sized magnet in the positioning stage of an extreme ultraviolet machine is the one physical object the entire network balances on. The ore that goes into it comes from mines spread across multiple continents. The refining that makes it usable runs almost entirely through one country. The process knowledge that gives it the grain structure and extreme ultraviolet stage demands is concentrated in facilities that the April controls make harder to replicate elsewhere while the work is in progress. If the qualification trials close within the suspension window, the network gains a genuine detour for the first time. If they do not, the machines that print the world's most advanced chips will, when the truce lapses, be dependent on a supply chain running entirely through the country that set the clock. That is not a geopolitical abstraction. It is the wire the magnet is hanging on. The truce did not change the shape of this network. It showed us, with unusual precision, where the network ends. The qualification trials for Western rare earth magnet suppliers are running right now, against a clock that expires in late 2026. Which node closes first, the bypass or the window? And what does the machine do if the answer is the window? Leave your read in the comments. If you want to watch that question resolve in real time, the map continues on this channel, so subscribe and turn on notifications so you catch the next readout when it lands.